division. Now I request Professor Uday Shankar Bellari sir to address the gathering.
Good evening, all. It is indeed a privilege to address this gathering on behalf of the Institution of Engineers Kalburgi Local Center. I extend my sincere greetings to all the participants. The topic for today's session, Fundamentals of 3D Printing, focuses on building a strong conceptual understanding of a technology that is redefining modern manufacturing practices. So, by adopting a layer by layer approach to fabrication, 3D printing enables greater precision, design adaptability, and efficiency compared to conventional methods. I th- and this session aims to provide a structured insight into a basic working principles, processes, and significance of additive manufacturing, thereby equipping participants with essential foundational knowledge. It is our earnest hope that this session will serve as a stepping stone for deeper learning and meaningful engagement in this evolving domain. Thank you. Thank you.
Thank you very much, sir, for your inspiring and insightful address. Now, it is the time to introduce our esteemed speaker for today's session, Dr. Sangamesh Rajole.
Hello. I want to welcome you to
We are honored to have with us Dr. Sangamesh Rajole, Assistant Professor in the Department of Mechanical Engineering, School of Engineering, Central University of Karnataka, Kalburgi. Dr. Rajole has PhD from NIT Surathkal, Karnataka, where his research focused on development of advanced sandwich composite materials for bulletproof applications. His research interests include composite materials, structural analysis, finite element modeling, numerical simulation, and material testing, which are highly relevant to modern manufacturing and additive technologies. He has over 6 years of academic and research experience and has contributed significantly to the field with 18 research publications, along with multiple citation and H index of 3. Dr. Rajoli is also a reviewer for several reputed international journals, including Journal of Composite Science, International Journal of Crashworthiness, Emerging Materials Research. His excellence has been recognized through multiple prestigious awards, including Young Scientist Award from DST and CSIR, Young Scientist Award by DK International Research Foundation, Best Paper Award at national and international conferences. He has actively participated in and contributed to numerous international conferences across India, Singapore, and Malaysia, and has delivered expert talk on advanced materials and composite technologies. Today, he will be sharing his expertise on fundamentals of 3D printing, giving us a strong foundation in this rapidly evolving technology. With great pleasure, I invite Dr. Sangamesh Rajole to take over the session. Sir, the virtual platform is all yours now.
Thank you. Thank you, Majid ji. I wholeheartedly thank Institute of Engineers and whole team Uday sir and then the Vishal Dutt sir and the entire team up from Kalburgi as well as from the main branch. So I thank that giving me the opportunity to share the talk on the fundamentals of 3D printing. Actually, I supposed to deliver the talk yesterday. Since a little technical difficulty, I could not deliver yesterday. And he delivered it, and all participants had how exactly advancement in 3D printing is happening. what different technology is being adopted, what different area it is moving. So what is the basis for it? How exactly it starts? That I think I'll be covering it today so that your confusion, sir has spoke so many things, but how exactly it has to start, where it has to start. So that was the confusion which I believe, and I'll start likewise. So all the participants, I request if you have any time, any doubts, and you can ask. So meanwhile, we can discuss rather than one-sided. You can raise your hand or you can unmute and you can speak parallelly so that it will be. And meantime, if I ask any small questions in between, you could be able to like react it so that the session will be live. I hope it is clear at their end also. So I'll begin sharing my slides. I Majid sir, can you confirm the slides are being shared and it is
Yes, sir.
visible to
Yes,
all
sir.
of you?
Visible. Yes, sir.
Yes?
Visible.
Sir, kindly make it full screen, sir.
Yeah, I'll make it.
So in the viewing option, there is a full screen. You
Now
can
is
choose
it full
that also.
screen?
In view option, there is a full screen option is there. You can choose that also. At the top, sir, at the right top. No, sir, in the Zoom screen itself.
Zoom screen itself. Okay.
Yes, just beside
Slide
that
control.
green strip, there is a view option.
View. Mute chat.
Fit to window 50%, 100% like that. There is an option, sir.
Right side, no? Application slide controls. Pouch.
Okay, anyhow, sir, it is also visible clearly. You can start from here itself.
Is it fine now?
Yeah, fine, sir.
Is it visible?
Yes, visible.
Okay. In that case, I'll proceed. So yesterday you heard so many things, how exactly it is proceed. But to begin, we should know how exactly we have to do the modeling also. To print any component, we need to know the modeling part equally. So I'll begin like this. See, by looking at the picture, what you can understand is it is an two-dimensional image, right? So whatever we thought that is been brought into the plain paper, but this is not sufficient to print, right? So similarly, again, we have artistic drawing as well as the technical drawing. So to begin, what is drawing? So we should have the technical drawing rather than the artistic drawing to 3D print. So if what is technical drawing, where all the required dimension will be mentioned. Length, thickness, width, radius, whatever the required dimension which will be mentioned in the product. So typically, let us assume that you wanted to print the glass. So this is how this 3D model will looks like you, and these are the different front, top, side, and the other views which you will be able to see. So again, one more model of engineering drawing. So you can see difference between drawing and design. Drawing where only sketching happens, whatever your idea is there, that you are going to bring onto the plain paper. But when it comes to design, you should have clear idea on, including the drawing, you should have the what is the material through which you are going to manufacture, what is its ergonomic, aesthetics, color, communication, every aspect of it, you should be knowing it. So that's what the complete design stands for. So if at all you have the design of particular component, then only you could be able to print any component. So we say that computer aided drawing, that is the graphical communication of engineers. Just like a language for us, like the way in which we are communicating, engineers will communicate in graphics. And it is a tool to communicate. In anybody's absence here, we could be able to communicate with our design or the drawing. So there shall be 2D drawing or the 3D drawings. And typically for printing, we might be requiring 3-dimensional product. And these are the different user interface which will be available. And there are many CAD models are available, starting from SolidEdge, SolidWorks, Gambit, Fluent, CATIA, Pro. Likewise, many drafting softwares are available where we will be modeling the components. So this is the general typical component which looks like this after the 3D model is being drawn. So what are the advantages of 3D computer modeling? Because we can do it, undo it, modify it, or any surface texture or anything which can be easily built in. So 3D modeling will be wireframe model or the surface model or the solid model. Any kind of models which you could be able to create, starting from nut and bolt to screw to house to helic. You can go up to the extent of aerospace engineering or the aeroplanes. Any sector you can do the drawing of it. So you can see why this modeling is equally important to animate and simulate before bringing into reality. Okay, so you can see the computer simulation, which is doing it, how exactly landing experience we can predict before really we can manufacture or actually land it. We can do the simulation a number of times by giving the proper conditions or the environment which are applicable for that, like time, temperature, humidity. Those are all parameters can be built in the software, and its simulation can be done for the planes, for the automobiles, for the submarines, anything, whatnot, we can do it. So you can say, you can 3D simulation of civil engineering, bridges, dams, structures. So this much of water with height, this much of pressure. So how exactly it behaves, or ballistic simulations, n number of things which we can do it. And where exactly these simulation will help, or the 3D printing will help you is, like after the, you can print the bodies, you can print the leg, you can print the hips, bones, anything for that matter, you can print. And for clinical trials can also be done on the 3D printed components before really undergoing to the actual operations or need to be done. So let us see now. I'll come to the 3D printing. The 3D printing is as simple as making a jalebi. But the process parameter here is how smoothly the raw material goes from one end to the other end. That's the equally important parameter where we need to control temperature, where we need to control the flow of the material. So when we have FDM. So likewise, so 3D printing, before printing, we have to create the 3D model, and it has to be sliced into layer wise. Then we have to load into the software which has to be connected to the 3D printing components or the device. if you connect that, automatically it will, and before that you should have save that file in the form of STL. So that will help the printing. So I think already yesterday Mallikarjun sir has explained how exactly it has evolved. 3D printing in 80s it has started. We called it as additive manufacturing, then fused deposition modeling. Since 2019, these patents are being expired. Since then, now the era has got and everyone is moving towards 3D printing of the component. Till these days, it was under patented contents. Hence, people like it was not available to all the people, common people. So those who has bought that patent, then they would have used this. But nowadays it is everyone, it will be available to everyone. So the common type of 3D printing we have is stereolithography, selective laser sintering, fused deposition modeling, twin light processing, and multijet diffusion. Likewise, many things are there, so you can go through, but commonly available 3D printing is like this. So this fused deposition modeling, FDM, so that you can see here is a common spool is provided here at the nozzle, where heating unit is also there, and it will be passed through the extruder head, through the extruder nozzle, and then the support material. On the base material, it is going to print the layer by layer material. It is as good as writing on paper, where what we are doing two-dimensional, that means thickness of that writing is very, very, very negligible. Whereas here, at every layer, every second, it is building the material. So that's what your 3D printing is. And every step or the every different technology, nothing changes, only the mode of printing changes. Everything will be more or less similar. So you have another technology called as fused filament fabrication. Typically, it is used in the composite fabrications, where the matrix filament will be there, as well as reinforcing continuous fiber is also there. So both will undergo and mix in the chamber, and then at the late, it is going to print layer by layer on the platform. Also, typically, it cures. So again, we have the stereolithography. How exactly this stereolithography happens? Just you can have one small video. I think it is let's see. I think you could able to see it. No. Okay.
Yes, sir.
Is not available. Something is issue. It's fine. So here also stereolithography also is as good as same, but here is the curable resin is there in the bath already, and the laser source is passed on to that. So because of the passing, the UV curable resin is that, because of the laser source, it layer by layer it just solidifies in the stereolithography process. So after the product is manufactured, it typically appears like this. So let us check whether it works or not. This is, I think it is not available, it is saying. Yeah, it's a very small video. I think it is visible to you.
Hey guys, it's Cameron.
Sir, it is visible to all, I believe.
Sir, visible.
Yeah.
Our school just got some 3D printers, and Nat let me borrow one to figure out how they work. To be honest, I've just been using it to print tiny cats. It's like a tiny printed cat army. Cute, but no idea how I made them. These printers look...
Hey Camry, I'm Cody Goldhunt, mechanical engineer and Nat Geo expert.
Wow, that thing really works.
What?
Nothing. So, Cody, can you tell me how a 3D printer shapes things so perfectly? Is it like a robot sculptor?
Not exactly. A person who sculpts stone removes chunks of a stone until it's in the desired shape. That's called a subtractive process. The 3D printer does the reverse. It's called an additive process. This means that the printer starts with nothing and then adds just enough material to make the same shape as a sculptor. It wastes less material than traditional manufacturing.
It looks like it's icing a cake.
Yep, it's just like a whole bunch of icing layers on a cake. A really hot extruder nozzle squeezes out liquid plastic layer by layer, right up to where the computer program tells it to. Once the layer is done, the extruder raises up just enough for that next layer to get squeezed out on top.
Can a 3D printer print with other stuff?
Oh yeah, you can print with plastic, ceramics, glass, metal. Some scientists have even found a way to print with biological tissue.
Wow, kind of like how I printed you.
What?
Nothing.
Possibilities of 3D printers are endless. There's many different shapes and sizes of 3D printers. They can print houses, dental implants, complex bridges, even pizza.
Printable pizza. That's so cool. So, how does the printer know how to print the exact shape of my cat toy?
Think about you and your computer as the toy designer. You draw a blueprint of anything you can imagine with your computer, creating a digital model. The computer then looks at your digital model, slices it up into layers, just like icing on the cake. Once it knows right where to put the icing, it tells the printer to squeeze out on that exact spot until the whole model is built just like your blueprints.
Wow, thanks so much for your help, Cody. You truly are one of a kind.
Hi, Camry.
I think it was too small, but it gives overall idea how exactly it is happening. Correct? So this is the product which are already printed with the help of them. So you can see the select to laser printing, how exactly the laser getting cued and then the product is getting developed in every steps. So different types of 3D printing which we have: metal 3D printing, plastic 3D printing. Metal 3D printing is at a higher cost and it is at the R&D level. But and plastic 3D printing, which we typically everyone will be using, this DLS method, DLP methods, these are all things especially which we are using in the medical fields. So these are the typical different types of printing machines which are available. And cost wise, again, we have very less cost for which already mentioned by the Mallikarjun, like even if you can purchase 10,000 rupees printer. But the difficult part is we will be having the standard spools, the feeders, but we have to design our own feeder. And recently I have been there at the Manipal, like, and they were using for many other tissue printing, many other purposes which they are using. Like Jalma is the one of the resin which they are trying to print the tissue with the help of that from medical background, which recently we shared the discussion. And these are the different field where the this 3D printing can be used, starting from the jewelry, orthopedic, and industrial applications, dental applications, or the chip manufacturing industries. So how exactly any modeling software which you can use for modeling purpose, but at the end you have to save it as STL file. That is the only part which we have to be remembering. Otherwise, it's all fine. So now I'll be going to give the demo how exactly this modeling will be done. So just open. What you can see, Majiddi, now?
PPT only. Your PPT is visible, sir, right now.
PPT is visible. Okay.
Yeah.
Just have to switch to share new, and then I have to show this. Okay. Share. Now?
Now also same PPT, sir. And now it is different window.
Yeah. So here, how exactly we will be doing the modeling? As we have mentioned in the previous slides or the previous speaker also, we have different modeling software starting from CATIA, ProE, and SolidEdge, SolidWorks. Likewise, many things are there, but for your understanding and what is already installed in my computer, that I'll show you the typical case. So this is the, like, we have the drawing, assembly, weldment, sheet metal, or the solid part. Typically, I'll show you the how exactly solid part is being created. So once you open the part, typically opens like this. Okay. Then you have to go to sketching. Once you go to sketching, here we have, like, the environment appears like this. You have the sketch, you have the protrusion, you have the revolved protrusion, and you have many more things for giving the dimensions, smart dimension, distance between the dimension, angle between. Likewise, many options will be there which you can explore further, but for how exactly we have to model it, and then how exactly we have to slice it, and how exactly slicing will be done, that demo I'll be showing you in couple of minutes. So here is the drawing which I have created. Let us see, select the sketch. Once you select the sketch, either we have the different planes called as XY plane, YZ and ZX planes. So typically I'll select this XY plane where the material is going to build up. So there I'll typically select a rectangle for easier communication purpose. So let us assume it is 100 by 100. Say enter. So 100 by 100 rectangle is being created. Let's go back. And this is how the things will come. Then you have to say finish. Then the material will be ready. Then here is the protrusion option where you can build the material. So say yes. So your material is going to build. So let us assume that this also for 100 mm you can build. So 100 mm material is built. So let us assume that you want this material is to be printed, and in that so many other complications are there. Let us assume that here we have one hole on top. So let us create a hole at the top. So because we don't know what is the center, so I can mark and align. Otherwise, make a line, or we can just take the center. Here, typically, I can take the center. I can select center. See, if this dot appears, automatically it appears to be at the center. Or I can come here and draw the radius of 20. Then 20 radius का एक circle बन गया. Then I can say finish, and then I can say select the cutout and say yes, then say yes. So now the material is being cut. Can you see it? And you can rotate it. You can see how exactly the material is being cut. Okay. So on that part, it is like that. And you can see, let us assume that in this part, so we want to build further material like. So you can draw the circle like this and come back and say select and say this one select and say like this. And you can build the material. Also, let us assume that we want to build further material on this side, and it shall be a rectangle. Assume. So written. So protrude. Select. Say yes. So you can put. So we have built the material. Now it is ready, and we want it to be printed. Okay. So how exactly we will proceed? Before that, as I mentioned previously only, it has to be saved in the form of what? STL file. So here we have the options of dot part, dot IGS, dot STL. So this is the typical part which we have to save. So I can say rather than part 1, I will say this as part IEI workshop. IEI 1 STL file. Then I have saved it. Right? So I hope it is clear how exactly it has to be saved, how exactly it has to be modeled. Okay. Like indicate that you are getting it. Okay, I'll find that. So I'll begin, like we have saved it now, and likewise there are many multiple components are there which you can explore further, and you can give the dimension also. So iska dimension chahiye to you can give the dimension, what dimension you like for this dimension, what is there, and for this circle what is the dimension which we have given. So anything for that matter you can give, and likewise, and it's quite easy, you can explore, and many softwares are there which are like free of like open source softwares are also there, you can explore it. So now we are done with what exactly is the modeling part which we have done. Now we have to go for printing, right? So printing, we have Cura is there, we have, that is typically it is for what is that, slicing purpose. We need to slice it, no, before that. So I will stop the modeling part now. I'll just close it. I think I'll say one more time. The STL file, stl.stl. One, to save. Okay. Now we have saved it. I'll just close. No. I'll just close this also. Okay. I'll share now. I told we have to use some slicing software for it. So I have installed Creality for it. So shortly it is going to open it. Wait for a minute. I think it is taking time. So what we have done is we have understood modeling, what is 2D modeling, 3D modeling, and then how exactly these modelings are being done. Now I will be sharing you the here I think sharing option is there. There is the Creality. Okay, this is what the Creality share. So I hope you all of you are able to see the this Creality software. Yes.
Yes, sir.
Yeah, thank you. Confirming. So once you are done, I mean opened it. So I'll just, what I'll do, I'll just minimize it. Rather than that, this I'll minimize and this I'll maximize. Okay. So you will be having the components like this. like PLA is the typical material which used. So they have mentioned clearly the filament is PLA. So here is this is the board where like when any 3D printer you take, there will be a platform on which you are going to print the material. So this is the platform where you will be printing it. So let us bring our model which we have created. So just we have to click on this. This is the add option. Okay. So if you click it, add option, and we have created the model by name II1. No. So just open it. So now the model is available here. Can you see this model? Yes.
Yes, sir.
And then you can slice it. See, here you have the option of slice all, slice plate. So let us do it, slice plate. It is slide, and you will be seeing the different models thing. And you can see here how exactly this slicing is done. Are you able to visualize it? It is as good as making jalebi? But only the thing difference here is material is different and process parameters are different. And only the difference is like that. And you can see when we are printing the metal, we have so much of difficulty because the temperature involved in, let us assume that you wanted to melt the aluminum. It has got almost 670 degree and more. That temperature handling is a quite very difficult. And when it comes to polymers, I think we will be operating somewhere around 200 to 300 degrees centigrade. So it is quite easier to print, but on top also it is difficult that standardized material is available according to for that the machines are being built up, which we will purchase manually. And this is how it start printing, which you are seeing here. And if at all you are and probably this will be available in your institute also, but just the thing is you have to go and explore it. And you can see these are the codes generated for the printing. And if at all you are from mechanical background, and SIM, there is a subject called SIMS, Computer Integrated Manufacturing, and even the SIM lab, where typically the students will undergo this G codes and M codes, which typically stands for X direction, how much distance you should move, Y direction, how much distance it should move, and G direction, how much it should move, and then what is the feed rate, feed depth, and what is the initial position. These all will help us to do the printing. And these all the G codes are generated once you slice it. Okay, so this will give you the clear idea on how exactly the model is built and how exactly the printing is taking place. So till now it is not printed. You can imagine how many codes it is been written to just print 100 mm by 100 mm a component. Okay, and if you think of the complicated parts of the cone which they have printed yesterday, that cone of the jet or the aerospace cone, though you can imagine how many codes are required and how exactly it would have been processed. So after that, so here is the option called send print. Once you send print, if your 3D printer is connected to your laptop, automatically it starts printing there. And this simulation parallelly that does. Or you can save this file. This file, and you can just copy this file into your memory card, and you can just insert to the printer which is available, or even through online also you can print these models if it is Wi-Fi, through Wi-Fi it is connected. So that is how we will be doing the printing exercises, and you can relate now the different exercises or the different case studies which are mentioned by yesterday's speaker on how exactly 3D printers works and how exactly they are working on. So I think I'll stop this. I think you have also followed this, I believe. And then I'll stop this one, and then I'll go back to our PPT. So this is where we have saved the file in the form of STL, and then we have submitted to the, or we have sliced it and then submitted to the printer, and the printing has started, and required material is being printed. So if you see this slide, typically it will give you the complete clear idea of the guide for how exactly 3D printing is happens. See, you can see start form and the mechanism, SLM printer, and the material extrusion, and materials pros and cons, that what are the different materials which will PLA, ABS, nylon, and what are the pros, what are the cons. Cons is, and then combination of metals and the materials, that also can be done. Common type of application where we can use, and details, process flow, conceptualization, and this, with this I could say that we have done our part. That modeling also I could have told you how exactly modeling is done and how exactly printing can be done. So we are left with another 10 minutes. So now it is open for floor for discussion. Thank you. One and all. So let us discuss what are your queries for the extent which I can able to answer. Otherwise, I will come back with new answer, or you can post also later. So now open to all for the discussion. I think I made
Participants are requested to post their questions in the chat box. Otherwise, they can unmute themselves and ask the question.
Yeah. I hope I have done my job, I believe. Like, as a beginner, everyone needs this, which I thought, and then I has prepared accordingly. And because it is a beginning, so to begin, it is very much essential, which I believe.
Sir, there is a small question from my side also.
Please, sir.
As you have said, as you have taken an input for the 3D printing from Solid Edge,
Yeah.
is there only one option, or any other software is there as an alternative for giving input?
Any software you can take.
Any drafting software?
Any
like
drafting
CAD?
software you can take. Only the criteria is you have to save it as STL file.
Okay, sir. Okay.
.stl it should be saved as.
Whether it may be 2D or 3D, it will take it and it will do it its own work.
Yes. 2D or 3D it will print, but 2D when it comes, no, there will be negligible thickness, right? 2D is as good as writing on the pen, writing from the pen, no?
Right, sir.
Yeah. If minimum thickness is there, it will be able to print it. Because 0.1 to start, it start with at least minimum 0.1 thickness, no?
Okay.
The first layer.
Sir, actually, sir, moderator, sir, any chat you can view from your side in the chat box?
Chart
No.
box.
Is no, sir, in the chat
No,
box
no,
also.
not yet. Okay. Chat box is somehow disabled. So, sir, a few participants have raised their hand. With your kind permission, we can allow them to talk one by one, sir. It is the only way for the one-to-one interaction with our panelists, sir. May I allow one by one? We have raised their hand.
Yeah, we can take up, sir.
Right now, I could not see any question posed in the chat box, sir.
The chat box is somehow something is now Dr. Satish Kumar, Dr. Bhaskaran from I know him. He is from Chennai. Bhaskaran, Dr. Satish Kumar and Dr. Bhaskaran both are here. So I am asking Dr. Bhaskaran to please, Dr. Satish Kumar first of all, let him, sir. I am allowing him to please come on the screen. Dr. Satish Kumar.
Am I audible, sir?
Yes.
Yes,
Please
sir, you are audible.
share your.
Sir, it was wonderful lecture. My question is general, sir.
Yeah, please.
What is the cost like? You know, if I want to have this type of facility for constructing some house, what is the range of cost for this type of 3D printing facility, sir?
Constructing house, exactly, I cannot say how much cost it might take, sir. It's again the research is going on further to develop it. But I can tell you if at all modular house or the small what is it, prototype house to build with PLA and all. Hardly it might cost around 1,000 rupees. That spool cost, and the printer cost might be around 25,000 rupees. And that spool cost is around some 5,000. Within 30,000, you could be able to make the prototype. But for building the entire house, I think still technology is developing, because as rightly mentioned yesterday by Dr. Mallikarjun, they are also working on printing up the houses. Initially, they are building the printer for that. Still, we have not came to conclusion, but other countries they are building it. But at this junction, I am not that expert to tell that this much cost exactly it will come for that house construction.
Okay, sir. Thank you, sir.
Thank you, sir. Thank you. But it is quite possible to print the houses, but it takes time in India.
Right.
Thank you, sir, for this kind interaction. Now I request Dr. E. Bhaskaran to please have a few words on this regard. Dr. Bhaskaran, please.
Yes, sir. Sir, thank you for giving opportunity, sir. Sir, I am sir, in Chennai, we have at Tirumudivakam, we have 3D metal printing and plastic, sir. Around 27 crore we have given from our Tamil Nadu government.
Wow.
We have a German mission, sir.
Really great to hear, sir.
EOS 290 and plastic 396, sir.
Wow.
I want to do research on robotics, sir. Whether I can print a robo in that metal printing, sir. It is a German mission around 15 crore, and one more plastic we are given around 7 crore, sir. That
Sir, where are you from, sir?
I'm from Chennai. There is a Tirumudivakam Industrial Estate. Tamil Nadu government has given 27 crore to them freely, sir. So
Oh,
they
ho, ho,
bought 15 crore German machine EOS 290.
And
So just
you
I
want
want to do robotics, robo printing. Whether it is can be done, sir, fully.
yes, it can be done, sir, but part by part.
Yeah,
It
part
can
by
be
part.
done part by part, hand separate, finger separate, and then we should know the mechanisms of finger, how exactly it should do, what motor we have to introduce in that places, what linkages we have to do. So those
Yes,
are
sir.
all things, mechanisms. It is internally we have to do it, and then assemble it.
In BE, I did 4 degree of freedom, sir. Scara
Okay.
robo with a chain and sprocket, a stepper motor. But
Oh,
now
oh,
I'm
oh.
interested in developing new materials, sir. So
Mhm.
where I can get guidance, sir? Do you have any idea? Because that person, they have only limited knowledge, sir. That machine who are having, he's from IIT Madras. He's
Okay.
PhD, sir. He's
Okay.
doing a lot of parts, but robo, you don't know. So I want to do on robo and get patent, sir. I'm in Startup Tamil Nadu. I am now in Startup Tamil Nadu, sir. You know, Startup India, like that. I am deputed to Startup Tamil Nadu, where a lot of new startups are coming. So I
Really
want to
great,
guide
sir.
them in
Really
Chennai.
great to have you here. I think we can connect with this Tihan from IIT Hyderabad, where a lot of work is going on
Sir,
3D printing.
what is name, sir?
Tihan.
Tihan. Okay, sir. Through
Yeah,
that I will search.
it is a subsidiary hub of IIT Hyderabad, sir, which is located in Hyderabad.
Okay, sir.
So they are working into robotics and then many things.
Hmm.
So
Sir, can you give your number also, sir? To any
Yes.
doubt is there, we'll contact, sir.
Yeah. We will be in touch, sir. I think I'll share in the chat box that and you can share me your number directly. So right now I'm sharing in the chat
Okay,
box
sir.
my
I think
number.
chat box we can't access. Okay, later I will through email I will ask her.
Yeah. Just now I have shared my number to all.
Okay.
Yeah, if it is available, otherwise you can note also, sir. 903661834
Sir, can you repeat it, sir? 90
366
90366
18
18
342.
342.
Yes, sir.
Okay, that name, sir, Hyderabad person name, what you said, sir?
Hyderabad, it is not a person, sir. It is an institute, Tihan.
P-I?
I think we can discuss offline, sir.
Okay, sir. Okay, thank you, sir.
Yeah.
Tihan, okay.
Yeah.
Okay, sir. Thank you.
Thank you, sir. Very nice lecture, sir.
Thank you.
Thank you, sir. Thank you. It's a pleasure, sir.
So, sir, apart from this, we have no more any raising hand or something. One chat has come after a long time. Oh, your number is here, sir. Thank you. So, may I now request our moderator, sir, please sum up the proceedings of the deliberation, sir, for today. It's
Okay, sir.
and very useful.
First of all, thank you, sir, for the highly informative and engaging session. Now I will briefly summarize today's proceedings. We began with welcome address, followed by encouraging remarks, highlighting the importance and applications of 3D printing by Professor Uday Bellari, sir. From Dr. Rajole's session, we gained valuable insights into the fundamental principles of 3D printing and how it differs from conventional manufacturing processes. Then we have seen various additive manufacturing techniques and types of 3D printing. Overall, today's session was quite engaging and has provided us with a strong foundation in understanding the essentials of 3D printing. As we come to the end of today's session, on behalf of Institution of Engineers, India Kalburgi Local Center, I propose the vote of thanks. I sincerely thanks to our esteemed speaker, Dr. Sangmesh Rajole sir, for his insightful session. My gratitude to Dr. Sriram Satyanarayan sir and Professor Uday Bellari sir for their support and guidance. I also thank all the participants and organizing team for making this session successful. Thank you all once again. Have a wonderful evening.
Thank you, sir. Thank you once again. I think we can sign up.
Thank you, sir. To all the participants, only an announcement that our e-certification link is open till tomorrow midnight. Anybody who want to opt for the CPD certificate, kindly go through the second link in the flyer and please opt for your e-certification, please. Thank you.